Okay. So basically, this is like a regular file, and you can see that in SPSS you have like all of these variables. But once you reach the propensity matching step, you don't need these variables because you're not going to find out new diagnoses or you're not going to run any new diagnosis code because you're already
Okay.
done. You've selected your know your patient population, everything. So you need to delete everything except the one that you need. So that would mean I would delete the key in. I have to delete this. I don't need it. Age. If the age I need, so I'll keep this one. I have to delete this one. Delete, delete, delete. I need to keep this. Need to keep this. And delete all of from here to ones till female. We need the female sex. Hospital ID. The length of stay you keep, but you delete these three. And
Okay.
again, you continue deleting till you reach PA1. Then you delete PR, which are procedure day. Again, you don't need these codes, you'll delete it. What this really means that you cannot do any changes to your patient population once you reach to propensity match score because
Yeah.
you're deleting everything. So you have to do that before you reach this stage. So you first get your data set ready, like what you want to do. Then you
Mm-hmm.
run a crude analysis, then you delete everything, and then you run a propensity match. So I'm going to make like a copy file, like save as, and do like an extra file here. Then I'm going to just delete everything that I don't think I need. So I don't need these. I'll just delete this. And deleting is very easy. You highlight,
You just delete. Yeah. Okay.
yeah, you just clear. It's just going to get deleted. So you have to do a lot of deleting here. So,
I see.
so I'm just going to delete everything. And then I'm going to delete all the diagnosis codes. Then I'm going to delete everything below pay. I'm going to keep the race and I have to total charges I don't know because we use combined adjusted cost, right? So we don't need this either. If you're not doing median household income in your analysis, remove it. If you're doing it, keep it. For this aspect, we'll think that we're removing. So I'll remove that as well. Then all this bed control, blah, blah, blah. I'm going to remove all of these. Trend weight, I don't know. I don't need these either. So I'm going to remove all of these. Then we have comorbidities. They're named here differently, but I'll keep them, I guess, just for so either elective diagnosis, discharge weight, we can keep one. Or usually we'll remove discharge weight and we'll keep combined weight. Because the combined weight, I made a variable combining two different weights. One is from before 2012, the other is after 2012. Because discharge weights apply to after 2012. And
Okay.
then we have a trend weight that applies to before 2011. So I've combined both of them into what we call combined weight. So you'll
Okay.
keep this and then you'll delete these diagnoses. Then these are your kind of like side effects, something. So you'll keep those. V1,
Mm-hmm.
V2, V3, V4 are your regions. So you'll keep that. Let's say you need this in an analysis. Then again, you go run through. So basically, you have to do a lot of careful deletion.
Yeah.
So again, you delete all your diagnosis code, everything. So once you
Okay.
do that, you've deleted everything except for your comorbidities, your complications, and your demographic data like age, blah, blah, blah. Then you have to confirm, you also don't need NIS strict or the NPR, which is number of procedures, or MDS, which is the discharge. So basically, go through each variable and delete most of them. The one that you didn't use, as simple as that, just delete. Then you
I
need to
see.
find out which variables actually have missing data. So to figure that out, you need to run this. Go to frequencies. This is the part I think you didn't do, so you didn't realize where is the missing data. And then you do
Yeah.
control
Exactly.
A. You don't want to do display frequency, it's going to make it very dirty. So just to undo this and then go to statistics. Just select anything like means.
Okay.
Um, just leave it empty. You don't need means. And then put this all over on this side. Now you're not going to have display table is unchecked, so no tables. You
Okay.
click OK, and now it's going to tell you exactly which has missing variables. So you can see
Oh,
here, see
I
missing,
see.
missing, missing. So your education primary pay has missing. So you can't get rid of primary pay because that's what you need. So obviously this 10 cases that have missing data are going to have to go. Then race, you have 575, that's about 10%, which is sounds accurate. And then if you go through everything else, you're not going to have any missing data. There's
Oh,
no,
I see.
the reason
Okay.
you won't have it because all of these are being calculated. So calculated doesn't have a missing option. It's either going to be yes or no, right? So there's no missing data everywhere else. But that's just a confirmation.
I see. Okay.
So now you figure out that these two are missing there. So now how to tackle that? Now you can obviously delete all the race cases 575, but that's going to be a huge missing data loss. You don't want to do that. So you have to run a syntax which you can do like new syntax, and you can just say, let's not do syntax for now. It's going to be a bit confusing. Let's do it through the regular. So let's go to
The
transform,
transform one? Yeah.
compute variable, recode variable, or compute. You can do each one. Um, let's
I
do
think
recode in a
like
different
from the
variable.
yeah, from the videos I saw on recoding, it was recoding to a different variable.
You can do it different way, but this is a better way not to delete the original for now. So let's do recode in different variable. And let's go
Mm-hmm.
to race.
Yeah.
And let's do old and new variables. So
Mm-hmm.
old is like 1 is going to be 1. That's your white. 2 is your black. So do that same. 3 is your Hispanics. We'll keep the same. 4 is your maybe Asians. I think you'll keep the same. And then 5, you want to just do 5, and 6 you want to do 5 as well. That's a single group. 7 you're grouping in the same group. And then what you need to do is system missing. This is the one we need to fix, right? Missing data.
Yeah.
And I want to put the missing data also in 5. So 5 is my other, or you can do 6, but I name it as missing data.
Oh, I see. Okay.
So let's do like 6. So 6. So you do continue, and then you name the variable as race recode. Now I'm going to show you something else here, which is a pretty neat thing in SPSS. Change. You see this paste? Always do
Mm-hmm.
this just for your own learning purposes. You click paste, give you exactly the code what you did. So what is the code? It said recode
Oh,
is the syntax. This is the command. Race
okay.
is the variable. And then you can see in bracket is saying 1 is equal to 1, 2 is equal to, 3
Hmm.
is equal to, blah, blah, blah. Into is again a core command.
Okay.
Then race recode is the new variable followed by a dot. So you can
Hmm.
save this and then in the future run by simply copying pasting this. And then
I
variable
see.
labels is a command, and then race recode dot. That's how I learned
Oh,
syntax. This is how you learn.
syntax. Oh, okay. Okay.
So anything you run command, it does also paste into syntax. So this is the syntax for the one that I run. You can see all of this. So once you copy paste this, it's going to give you this thing automatically next time.
I see.
So anyway, that's just a learning point. Let's go where is
Then if you ran the same one you did before, it will show that the race is nothing missing again, right? It will
yes.
be
So
zero,
now
basically.
you can see it's recorded. So now let's run the missing again. So frequencies, but this time you have to put race recode, and we run it
Mm-hmm.
again. Now you're going to delete the original. You can see still 575, but how much is in
Yeah,
race recode? 0. So now you
got it.
save the 575 cases that would have been originally removed. You don't want to do that.
Mm-hmm.
So because you don't want to lose a lot of data. So now you can go down to race and delete race.
Okay.
And you have to do this race recode before. So it's also there in your original data set, right? Because even in original data set, you need to have like an other. You can't have a different race set in propensity match and a different race set in your original data set.
Mm-hmm.
You
I
get
see.
that part?
Yeah, yeah. Got it.
Good. So
And what did
now
you do for the 10 cases of the bay?
exactly that's where the other code comes in. So I send you a code. I'm going to
Mm-hmm.
explain you what that code means. There's a way to do it in, but this code is much more easier. So let's open the syntax code. Should be missing, I think.
Yeah, I think it was missing. Yeah.
Or delete something. I don't remember what was delete. Okay,
Yeah,
delete
delete
something.
all missing cases one. Yeah.
So now I open it. So this says select. So this is what I realized, that these are the only time when you're going to have a missing data. Right? So if you run this, it should work almost all the time, because these are the only codes where you're going to have missing data. You're going to have missing data anywhere else. So what
Okay.
this is, that select, but do this at the end when you're sure now. Okay, now I want to remove cases. Don't do this in the beginning, because then you might. If I ever run this in the beginning, I would have lost 575 cases from the race code.
Oh,
So
I
what
see.
it is, that select a case. If not means like if there's no system missing any missing data in this variable. So that's what the code means. So died is the name of the code. You can write anything here, whatever variable you want to remove. So if you go back, there was the pay one was the one that had 10 cases. So if you just run this one, and it's run to check the syntax output, it is already run. So now you just run it again, and you see there'll be no missing data. So now you can run the
Oh yeah, it
propensity
says
match. So all the missing data is
it
0.
said 0, yeah, for the pay. Yeah.
So that's how
I
you
think
get
it's
rid of missing
yeah,
data.
I see. But
So
usually you don't do this step unless like there's just few cases and it's okay even if you lost these like 10 cases or
yeah,
whatever. Small
exactly. I
number.
mean, you have no other choice. You can't run a propensity match analysis without with presence of missing data. You have to remove all missing data.
Okay, got it.
So missing data removed. Now you run it and you get your results. I don't want to run the code on this because I have to type a lot of stuff. So, but
Oh yeah, yeah,
yeah, run a code, and this is how you get rid of missing data.
yeah.
So
Okay.
now, how to select cases? That was the other question. So we open another syntax, and this time we go open syntax, and I think I've emailed you this as well. Select cases. I think I've named it as extract case. So,
Yeah,
so this is again a syntax, and again it's very simple. So this is the name of the file. Get this file, and this is where it is in my computer, it's in the D drive. It should be named as 220 these days because it's updated. But whatever is the file name of the master data set, it's here. Get this part. So in your computer might be C drive or whatever drive it is.
yeah.
This is where your location is. Then you say the
So
data set.
what's only above 17?
This is the name of the data file.
Oh, okay. I see.
And what it really means that I've removed the pediatric cases from the data set. But I'll
Yeah.
send you a link for the master file. So just put the name of that file here. Then
Okay.
you name the current data set, like this data set. It will be named as data set 1. Then you want to copy the file into a new data set. So that's what it means. Then you activate the new data set. Then you remove all filters, like you don't want any files to be excluded from copying cases. That's what it means. Then you say select all. If here is what you need to put them, so whatever you want to select. So
The diagnosis coded or procedure or whatever.
exactly. So whatever code, it's the same as anything, like diagnosis 1 is equal to this. So any logical equation you can put over here. And then you just click execute, and again you put the same code to select which data set you want. You want these data sets. And then here you can just put whatever you want to save. Like you want to name the new set as XYZ or whatever you want to name.
Oh, I see. Okay.
So you just copy paste this and it's going to automatically done. You can go have a cup of tea, and when you're back, it's going to be done. I used to do it manually, and then I used to do individual years, and then I used to like merge them together. It was a whole pain, but this is very simple.
Oh, okay. I was wondering how do you usually like this data set of from long years. I thought
So
it's a complicated process.
yeah, I mean it is complicated if you don't have the main data file. That's why I usually don't like sharing my own data file with other people
Yeah, yeah,
because
makes sense.
there's several reasons. One of the reasons is that there's a lot of hard work going into it, and the second reason is like if something goes wrong, they're going to blame you for it. So I don't want to be, unless I'm on the paper, then I'll take the blame. But
Correct. Yeah.
uh, because they are, so you have to check your, there are possibilities of error because if you're merging so many data files, who knows, you might have done something wrong.
Yeah. Yeah.
So anyway, I'm going to email you this as well, but just try to, all of syntax code are just like a mathematical equation. Just go through them again and again. You'll understand. It's not that complicated.
Yeah.
You have to just tell the computer what do you want. That's what basically it means.
I see. Okay.
So save is mean save, data is activate, which data set you want to activate. It's pretty much simple. And you can write one command in several different ways. So that's it. So
Okay.
try it. It should be easy. I
Yeah.
don't I don't think it's going to be a big. So you just need to kind of understand why are we doing it and what are we doing. So
Correct.
extract should
Okay.
be easy, but the traditional way how we extract, if you forget how to do this, then you just go to data, you go
Yeah.
select cases, you go to what do you want. So obviously you want to do select if, and then you paste the code over here.
Correct. Yeah.
Whatever, like you say, if diagnosis 1 is equal to 321, for example, that's your code. But you have to remember it's a string. So string has to be in commas.
Yeah.
Numerical is not in commas. That's what it means, right? And then you
Yeah.
do continue, it's going to select some cases. So you do continue. Now, what does it mean that there's no diagnosis 1? Obviously, we deleted our diagnosis 1. But anyway, let's
Yeah.
say you want to do, now, if you want to select only age is equal to 33, you don't need to put it comma because it's a numerical variable. So now it's going to only select age 33 people, and then you can name the new data set whatever you want, and then you click paste. I'm going to just show you what it shows.
Yeah.
Where did it go? Here you can see it's the
Okay.
same.
Yeah.
See data set copy, blah blah blah.
Nice.
Select this.
Mm-hmm.
Here, remember this is what we put in. This is the code. Age is equal to.
Yeah.
So put anything
Yeah.
and then. So pretty much like that.
Yeah.
So that's how you run syntax. And
Okay.
whenever
Yeah.
you run
This
a
is.
yeah, when you run a command, it should be printed out here. See, all of the commands are printing out here. This is your
Yeah.
syntax code.
Okay. Yeah.
So
I
yeah,
think
that's
this is a very good way to learn how to write the syntax. Yeah, as
yeah.
you said, we can just save all this and use it in the future.
Okay. So yeah, and then there are some other stuff. I think there are some R stuff as well. And when you have time, you can go through them as well. Or I'm going to just email you there like some scripts. I've kind of cleaned them, like
Yeah.
forest plot especially. You would need that. This one.
This one. Yeah.
So basically, this is your command core, command only. It's just a couple of lines. These are your packages that you would need. This is just how to read the file, and then this is the only command. That's it.
I
Then
see.
I've also there's like a data file in which you just paste up your stuff. So I'm going to email both of these to you. I might
Okay.
have emailed you already. I don't know.
I think I have uh the New
Yes.
England Journal of Medicine.
So
No,
this
I
is
don't have
your
this one. No.
yeah.
Yeah.
So this data set, like this is where you need to put your like variables. This is
Mm-hmm.
empty. So if you have like if you want to put your numbers of like cases like 333 or 23, whatever, you can put that here or just leave it empty. And these are your odds ratio. You just
Okay.
put this in your data set and then you just run that code. You should be able to like create a plot.
Okay.
Obviously, you will need a plot for every case.
Yeah.
You can like for other like line bars, etc., just use Excel. It's easier to use. Okay. Any questions on this?
No, I think this makes sense right now. I can try replicating that on the infective endocarditis one, and I'll let you know. Should be okay since I will get rid of the missing ones. So
Okay. All right. Well, so yeah, we can have another session if you need anything else.
yeah.
Um,